So in this problem we have a spherical shell with surface charge density sigma, and this spherical shell has a hole in it. So we want to find out what is the electric field right outside the surface in the middle of where this hole is. So the trick is to describe this spherical shell with a hole in it as two objects: a solid spherical shell with no hole, plus a little bit of surface with the opposite charge that goes where the hole would have been. So this is just a patch of surface, but if you add the patch of surface with negative charge to the solid shell with no hole, it's the same as having a shell with a hole. So if we calculate the field of the positively charged shell plus the field of the negatively charged patch, it gives us a total field of the shell with a hole. So let's look at just the first of these objects, a solid shell with no hole. It has a surface density sigma. So the electric field right outside the surface, what is this? It's given by Gauss's law. And we can just, to apply Gauss's law, we just draw a Gaussian surface just outside the surface of the shell. And the electric field times the area of the surface is equal to the charge inside, which is the surface density times the area divided by epsilon naught. So the areas cancel out and the electric field right outside the surface is given by this, and it points radially outward. So we know the electric field of a solid spherical shell. We call this E+. Okay? So what about the other object? If we look at just a patch of surface with the opposite charge density, a negatively charged patch. So this is our patch of negative charge density. So if you're very, very close to this patch, it looks like an infinite plane, because if you're very, very close to this patch, to you this little circle of charge looks like an infinite plane. So we know the electric field produced by an infinite plane at that point. So this is given by sigma divided by, or negative sigma because it's negatively charged, divided by 2 epsilon naught. And this field points towards the plane, so it's a field going into the plane. So this is the electric field, and it points radially in. This is the electric field of this negative patch of surface. So the electric field of the spherical shell plus the patch of negative charge is equal to the electric field of the shell with a hole. Okay, we just add these two fields that we've already calculated, and that gives us a total field of the shell with a hole. Points radially out, and it has this magnitude.